Okay, so any moving objects, okay, any moving objects, it has mass, we know for sure, and it is moving, so it will have speed also, it will have velocity also. So when the object is with a mass m, okay, any kilogram, okay, maybe 10 kilogram or 20 kilogram, and it is moving at a certain speed, maybe 2 or 3 meters per second, we say the object has momentum. Okay, momentum. So this momentum is only available when the object is moving. When the object is not moving, it doesn't have any momentum, right? So the momentum is a vector quantity. That means if you are moving forward, the momentum is positive, for an example, and if you're moving backwards, the momentum will become negative. It is a vector quantity because of the quantity velocity. Okay, mass times velocity. So that will be the formula, and because of velocity, it is a vector quantity also. So forward momentum can be considered positive, backward momentum can be considered negative, or anything opposite direction is negative. Remember, in physics, everything that is opposite direction is negative. And the unit for momentum, it is given by, according to the formula, mass times velocity, so kg meters per second, or you can just write it as Newton second. Okay, these are the momentum. So whenever we are dealing with momentum, you have to always obey the principle of conservation of momentum. Okay, if the question say the momentum is conserved, okay, that means that the total momentum before the collision must be equal to the total momentum after the collision. So that is the principle of conservation of momentum. Okay, total momentum before is equal to the total momentum after, provided that there is no external force acting on your system. The meaning of system here is how many objects that you have that are colliding with each other. If you have two balls, that means only the two balls are acting against each other. No other force. That means you cannot consider friction, you cannot consider other things. So basically the principle is based on a perfect situation, a perfect system. Okay, no other forces, no other energy loss, no other changes occur during the process. Okay, during the process of collision. Okay, so this is the full definition for momentum. So if you require 2 marks for the momentum definition, you have to explain the two sentences: total momentum before equal total momentum after, and there is no external force acting on the system. That will give you the full marks. Okay, so from that understanding, okay, we can change it into a mathematical form. So total momentum before equals to total momentum after, and we know momentum is mass times velocity. So if you have two objects, that means both of the objects will have their own masses and their own velocities. So total momentum before and after can be given as this formula. Okay, this is the full formula for momentum. Right? Sometimes books will also give only MA UA equals to MA VA. That means they are only considering one object. They are not considering two objects. But for you to find total, you require two objects. Then only you can add up. Right? You need two numbers to total up. It cannot be one number and you total up. There is no such thing, right? So that's why you need to add the momentum of object A plus momentum of object B before they interact, before they collide, equals to total momentum of object A plus total momentum, the momentum of object B. So you get the total of A and B together. And that will be the basic formula, that it will be the main formula for momentum. Okay, so we can actually make it into a graphical form where object A has mass A moving with the initial speed, which is UA, right? And then it will collide with object B, which has a mass B, MB, and velocity UB, initial velocity. So after the collision, object A still the same mass because mass cannot change, right? And it has changed speed after colliding. After it bumps into ball B, it has changed its speed to new speed, which is a final velocity, which is VA. And then object B also has changed. So it depends whether the object is moving or not moving. Okay, you just need to substitute accordingly to the formula. So before the collision, the momentum of A plus with the momentum of B before collision. After collision, momentum of A plus momentum of B. So total and total. And these two totals must remain the same. That means must be equal. That's how you get the formula. Right? Any value that you need, mass, velocity, you just have to consider initial and final. That means before and after. So in collisions, basically there are three types. Okay, there are three types of collisions. Only that in mainly in IGCSE books, they do not tell you what type of collisions are there. They just tell you that they are colliding with each other. Okay, so there are three types called elastic collision, inelastic collision, and also explosion. Right? So in the difference between the elastic, inelastic, and explosions is about the after collision, okay, or before collision, something like that. Their condition before or after the collision. How are they acting after that? Let's say the two balls, they collide with each other. After they collide, what happened to them? How are they moving? So it depends on that. So elastic, after they collide, both of the objects will move separately. Okay, before they collide with each other, they are already separated. After they hit into each other, they move, they are also still separated. They are not combined together. Okay, so after the collision, objects move separately. So in elastic collision, the momentum must be conserved. That means total momentum before must be equal to total momentum after. Total energy must also be conserved because we already say that there is no external force acting, no other heat loss or no other energy loss. So that's why the total energy is conserved. And the total kinetic energy is still conserved also. That means if the kinetic energy of A plus kinetic energy of B before the collision will still be remain as total kinetic energy of A and B after the collision. Okay, so the total still remain the same. Remember, not each individual kinetic energy, but total, the sum of both of them. So if I say before the collision, object A kinetic energy is 5 joule. Object B is also 5, maybe object B we make it 10 joule. Okay, but after the collision, object A has increased to 8 joule. Okay, but object B must reduce to 7 joule because the total must remain as 15. Individually, they can be different kinetic energy, but the total must remain still 15. That is the meaning of it. Okay, so the main formula applies for this situation because they move separately. So they have every time they are moving, they have different velocities. Okay, whereas for inelastic, okay, that is the kinetic energy formula. For inelastic, before the collision, they are moving separately. After the collision, they combine together and move together. Okay, that means ball A and ball B has stick together and now they are moving together. So when they are moving together, they have a common speed. They have the same speed after the collision. Okay, after the collision, the object moves together and their masses are combined and they move with a common velocity v. So no more different velocities after collision. It's the same velocity for both of them because they have stick together and move together. So still total momentum will be conserved. That means still the formula applies. Okay, total energy is still conserved, but kinetic energy is not conserved already because kinetic energy earlier was because of separate masses, mass A and mass B. Now mass A and mass B has combined because they combine together and move. So the mass has become maybe double or maybe more. So when mass become more, kinetic energy will also become more. That's why it's not conserved. So kinetic energy before and the kinetic energy after is not the same. That's why it's called not conserved. And the last type is known as the explosion. So explosion example would be like we are firing gun, okay? A bomb itself splits into fractions, okay, the debris of it. So that is explosion. So in explosion, before the collision, it is one object, okay? It is one object. It may be moving or it may not be moving, like a bomb, okay? Like a bomb. Bomb can be placed in one position, it is not moving. Or it can be placed in a moving car, so it is moving. And then when it explodes, it will break into pieces. So for analysis purposes, we assume it breaks into two pieces. Okay, just for analysis purposes, it breaks into two pieces. So basically from one mass, now it has become two masses, smaller masses, but both of them are moving in opposite direction of each other. Because when explosion happens, it will break into separate directions. Okay, so after collision, the objects separate and move in opposite direction. So anyhow, it is about momentum. So total momentum is still conserved. Okay, energy, it is still conserved because we already assume that there is no external force or no friction or something acting. Okay, but the kinetic energy is not conserved because of the mass difference. Because earlier, both of the masses combined, so they are heavy. Okay, the bomb is heavy. But after that, it explodes. The parts of the bomb become smaller parts, so they are not so heavy. So that's why the total kinetic energy is not conserved. So for this case, the formula will be slightly manipulated again, because earlier the two masses are combined. So we assume the heavy mass, Ma plus Mb. Right, so the formula will be slightly manipulated again. Anyhow, the formula still basics is still from the same principle of conservation of momentum formula. Only the difference is based on the condition. Here in this condition, remember, it is one object and then split into two. So the mass before the collision must be bigger compared to the masses individually after the collision. Okay, so we assume that it breaks into two parts. Okay, of course, when a bomb explodes, it doesn't break just into two parts. It breaks into many parts. But for analysis purposes, we assume into two parts. Or it can be maybe two of you, okay, are riding on the same skateboard. Okay, two of you are riding on the same skateboard. Then after some time, you guys are moving. One of you jumps off the skateboard. So that means when you jump off, you need to exert a force to the skateboard, and you will jump backwards. So the same situation, okay? Or it can be when you are shooting a gun, okay, rifle, firing a rifle, also the same thing. So something like this, explosion examples. So when you're shooting a rifle, the bullet will move forward, but the gun will cause you to be jerked slightly backwards. You will move slightly backwards because of the forward momentum of the explosion during when the bullet is going out. Okay, so the rifle will experience a backward momentum, opposite direction, and the bullet will be forward momentum. So it's moving forward. So that is an example of explosion. You can have a balloon. Okay, when you release a balloon, you blow air into the balloon, and then you release it. So the balloon will fly up, but the air will be flowing down. Because of the air flowing backwards, there is a reaction force which is pushing the balloon forward. Okay, there is always action and reaction. The forces will never be in single form. Forces are always in a pair or more than a pair. So these are the situations that you can have related to momentum, but it is the case of explosion. Okay, and from understanding momentum, okay, actually they came up with the Newton's second law of motion. Okay, from understanding momentum itself, because we know that when an object is moving, the object can be moving faster, sometimes can be moving slower. So the speed or the velocity can change. So when the velocity changes, means the momentum changes. So momentum can change over time also. As speed changes over time, momentum also changes with time. Right? So you can have final momentum minus initial momentum. You can have change in momentum. So this will mean it is an impulse. Okay, change in momentum means an impulse. So when momentum can change after 5 seconds or after 10 seconds, that means the object can be considered as moving faster or moving slower. So same thing, okay, because velocity changes. It can be moving faster or moving slower. It depends on the situation. So when this happens, okay, you can create a formula where the momentum, the change in momentum occurs for 2 seconds, or the change in momentum occurs for 0.1 second. It depends. So for some time, if you take the longer, okay, you won't experience so big force. If you move slower, so you won't be experience. You will move faster. Maybe the something is bigger. The change in momentum is bigger. It depends on how fast you change your momentum. Okay, how fast you are moving, then you press your brake. Okay, if your car is moving at 100 kilometers per hour, and then you press your brake slowly. So when you press your brake slowly, you won't experience any difference. It's like you are just slowing down. But try to, when you are moving at 100 kilometers per hour and you press brake suddenly, right? When you press brake suddenly, automatically your body will not be ready for that stop. So you will jerk forward. You will jerk forward because you automatically brake the car. The car is ready to stop, but our body is not yet. That is the inertia of your body. Okay, so that is a change in momentum, which is suddenly. Okay, suddenly means in a fraction of a second. In a fraction of a second, you suddenly change your momentum from moving very fast, suddenly become very slow. That is the idea. Okay, that will give you a sensation of a big force. Suddenly you are like experiencing a very big force. That is known as an impulsive force. So you see, when you relate to the force, now you have the force formula ready. Change in momentum, which is occurring for a sudden period, for a very, very short time. Okay, it suddenly changes. So this usually occurs in accidents, because your car is moving very fast, suddenly you go and hit into a tree. So your car suddenly stops. See, fast and suddenly stops. So that's why you experience a very big force. So your car will be spoiled because of the big force, impact force. That's why it's also called as impulsive force, impact force. So your car will be experiencing a very big force. It will brake a lot, basically. At the same time, your body, you are sitting in the car, you will also experience a force forward because your body is not ready to stop. Okay, that is inertia. So your body will only stop when your brain can process the whole situation. Okay, because it is happening very fast. So our brain will take a little bit of time. Okay, very short period of time, just to counter again the change. So the inertia. Okay, so that's why we can have the formula, which is the resultant force is equal to mass times acceleration. So this formula came from the understanding of momentum. When momentum changes for a quick time, that's why you have impulsive force. So the force is always a resultant force, because when your car is moving, okay, it has a forward force. At the same time, tires will experience. The tires will also experience frictions. So friction is on the opposite direction. So you see, whenever you are dealing with forces, there is not only one force. Always there is one more or two more forces. And your car is moving through air. So there is also air resistance. Right? And then suddenly you go and hit into a tree. Your car suddenly stops. So when you hit the tree, the car is exerting a force onto the tree. And the tree, on the other hand, is exerting a force onto your car. Okay, action and reaction. So the tree does not break, but your car breaks. So your car breaks means your car is being pushed into different shape. So there must be some other forces that are doing it. So the force due to the tree. Okay, reaction force due to the tree. Only that this change happened very fast. Okay, the change happened very, very fast. So that gives you the understanding of impulse together with impulsive force. So that means the net force that we are calculating using the formula F equals to ma is also can be considered as impulsive force when you are dealing with momentum. It is called impulsive force because the time of the change is very quick. Okay, it is quick change in the time, short period of time. Usually will be a fraction of a second, 0.02 seconds or 0.05 seconds. Okay, but if the force is acting for a long time, then it is not called impulsive force. It is only known as force. Okay, just like when you are pushing a box, you went to the box, you put your hand onto the box and you start pushing. You start pushing all the way for 5 meters. So your hand is touching the box and your force is acting for a long time. So time is long. So that is not called impulsive. You are not spoiling the box at all. You are not breaking the box or something. You are just pushing the box. So that is called a normal push by a human. Okay, remember, impulsive force only occur when the rate of change of momentum is happen very fast. Okay, it's a quick change in the momentum. So as we know, right, when you exert a force onto an object, okay, when you exert a force onto an object, the object will start to move. So the force can make an object to move, can change direction, or can change the shape of the object. So that is the whole thing. Okay, it will go back to the same understanding of what a force can do. So can accelerate, can decelerate, can change direction. Okay, moving forward become moving backward, or moving forward become to moving rightwards. So because of the force. Without the force, nothing can happen. You will maintain in the same direction only. You will maintain in the same state. So how do you usually reduce impulsive forces? Okay, because impulsive force can cause damage. So you need to avoid that. So in sports, usually, let's say you have a high jump. Okay, they will, after the person jumps high, and then he will fall down onto a quite thick cushion. Okay, thick mattress. So this is actually to increase the impact time. Just like I said, you have a very big damage if the impact time is very short. So if you like make the impact time longer, the impact will be, the force will not be so big already, right? So the damage will be lesser. So reducing the resultant impulsive force. So you use a thicker mattress. For baseball players, when they get the ball, okay, when they hold the ball, right, they will move slightly backward their hand. Okay, that is actually to reduce, again, to increase the time, reduce the force, but to increase the time where the ball comes and hit your hand, okay, hit your palm. So again, to prolong the impact time. Just by prolonging the impact time, you can reduce the force. Okay, so fragile foods, the same thing. They will put something soft, something which is soft. Okay, just like when you buy any electronic device also, they will have polystyrene, white color, as a cushion for your devices. So again, that one also, when you throw the thing, you can still put it in a certain manner, slightly harsh, never mind, but it won't spoil your devices. The eggs also, they have their own carton. The carton is made of something soft. So something soft will always provide a certain a leeway or a certain gap between the impact. So again, lengthening the time of impact. So usually our cars are built longer in front and shorter at the back. Okay, and they put engine in front also. Before this, we have cars such as the Beetle, right? They have engines at the back. But problem is, when you have engine at the back, and most of the time we will be experiencing accidents from the front. Okay, most of the time, I don't say from the back we don't, but from the front most of the time. And most of the time it causes fatality. It causes people to die. So therefore, they came up with a different style, changing to the engine in front. Okay, and make the front part of the car become longer. So if you notice that most of the BMWs, Mercedes cars, they have longer front and a shorter back. Okay, that is actually for the explanation D, the crumple zone. Okay, the crumple zone will be longer now. So when you hit from the front, it will take time for the force to reach to you. Okay, it will take time. So again, you lengthen the time. When you lengthen the time, you reduce the injury to yourself. okay, the car will anyhow experience the injury because the car will first experience the force. When you hit into something, the car will experience the force first. So that force you cannot control because it is action reaction with the whatever wall or whatever tree that you hit, right? So the car will anyhow spoil. But there is a leeway there. Okay, there is a time that is being delayed between the front of the car and you inside the car. So there is a delay. So when you delay that, you reduce the force on yourself. Okay, so human safety is important first. Okay, so that's why they came up with that. So other than that, they also created airbags. So airbags, another cushion also to prevent. First of all, is actually to prevent the driver from hitting the front, because sometimes maybe the your seat belt doesn't work. Okay, your seat belt doesn't work. So the airbag will come off, right? It will be in front of you, so you provide a cushion and avoid you from hitting the dashboard, right? Or nowadays they also have, if you notice that if you have license, then maybe you can experience that. Okay, you put on your seat belt, and if you press your brakes suddenly, okay, automatically your seat belt will lock. Actually, it will lock and you cannot move forward, right? That is also another safety feature that they have already included in cars. Okay, automatic sensing system. So if you press a sudden brake, the system will automatically activate the lock for your seat belt. Okay, then they have the anti-lock braking system. Okay, eliminates the need to pump brakes when you have to stop quickly. Okay, so that means your brake, if you press suddenly, okay, it will be having again a certain period of time. Okay, so that you doesn't stop immediately. If you stop immediately, your body will immediately move forward, because that is the inertia. Your body is moving with the speed of the car. So your car stops, but your body is not ready to stop. So you need a reaction time there. So our brain will take some time to react to the situation. So that's why we need some delay, something else to delay the whole experience of collision. Okay, other than that, they have safety glass, headrest. So the safety glass, the windscreen usually now is designed not to break into pieces so fast. Okay, so they will break into small pieces, and then only they will shatter down. So that is the whole system that they create. So if you are if you are interested in doing automotive engineering or something, so you need to know all this. You need to know how to work with all this. Okay, how to actually increase more of the or delaying more of the impact time. So example questions. So you have two trolleys, two trucks, A and B, 6,000 and 5,000 kilogram. A is moving, but B is not moving. So calculate the momentum of A. So momentum of A means you only have to focus on truck A. Just use the momentum of A. So after collision, truck B has momentum 27,000. So you know after collision of the truck B. Impulse applied. So impulse is just the change in momentum. Okay, let's see. So these are the information that we have. Initial speed, we don't have final speed, so never mind. So momentum of A, MA, UA, simple, before the collision. Okay, it's simple. So after the collision, B has 27,000. So according to our condition, we know that total momentum before must be equal total momentum after. So before the collision, only A has momentum, B is 0. So 30,000 plus 0 is 30,000. But after the collision, 27,000 taken by B. So that means remaining 3,000 is taken by A. Okay, so the question say determine the impulse. So impulse is equal to change in momentum. So initially, truck B has no momentum. After collision, it has momentum. So change in momentum from 0 to 27,000. So change is only 27,000. So they were in contact for 0.6 seconds. So again, a fraction of a time. So fraction of a time will tell you that this is an impulsive force. So it happens very fast. Okay, they got and collide with each other very fast. So force can be calculated by change in momentum divided by the time. And you are talking about truck B. So truck B, just focus on truck B, how the momentum of truck B changes. So you know the change is 27,000 and the time taken 0.6. So the force acting will be 45,000. Very big force. You see, that is why when the impact time is very short, the force acting will be very big and it will cause a lot of damage. Okay, the final speed. So after the collision, they are moving basically with a separately. Okay, they didn't say in the question that they combine together or move, so they move separately. So you have to know the final momentum. Okay, final momentum of A, as we have said earlier, because 30,000 is total before and 27,000 is taken after the collision by B. So remaining is 3,000. So that is what you need to do, 3,000 first. So you know the momentum of A after the collision. So you know momentum, you know the mass. So we can find the final speed. Okay, another one, you have a hammer hitting a nail. So hammer is 0.15 kg, speed of its moving is 8, and it hits the hammer head and the nail for the period of when they are in touch, when they are in contact is 0.051. Again, a fraction of a second. So it should be impulsive force anyway. So they can name it anything, average force, okay, but the situation is about impulsive force. So again, change in momentum, mv minus mu of the hammer head. So just focus on the hammer head. So impulse given to the nail. So the nail initially not moving, then become moving. So change in momentum of the, so whatever momentum occurs for the hammer head, it will go into the nail, because we know change before and after must be the same. So after the hammer hits the nail, the hammer stops. So whatever momentum that had by the hammer will be given to the nail. So the same as the hammer. So average force, change in momentum, divided by the time of contact. So change in momentum is 1.2, time of contact is that, so it's 800 Newton. So almost like 80 kilogram of mass is being added to the nail. Even just by hitting it in a very, very short period. You don't have to hit it very hard. Okay, you keep on hitting it with the shortest period of time is contact. Okay, shortest period of time of contact as possible. So you can have particles hitting the wall, okay, creating pressure. So again, during the pressure, you must also mention about change in momentum. So this is the situation. Okay, when particle move towards the wall, have some certain speed. Move away from the wall, have another speed. So important here is momentum is equals to mass times velocity. So velocity is very important. So that means if you're moving to the left, we assume positive. To the right means negative. So initial momentum, final momentum, you have to use negative. All right, so there will be a change in the momentum. So basically the momentum become bigger because negative and negative become plus. All right, so that's why you need to know about the directions here because of velocity. Right, cricket match, catcher caught a ball, mass 5 gram, moving with the velocity 15. Time of impact between the ball and the catcher is 0.2. Again, a fraction of a second, so it should be impulsive force. So initial momentum, final momentum, because the ball stops, so everything goes zero, your hand also stops. Okay, so change in momentum is final minus initial. So because you are talking about the change, so you are not concerned about the negative positive, because negative positive means direction. Here you are just talking about the change, how much the change is. So that's why the negative is neglected. So impact force divided by the momentum divided by the impact time. So you get 0.4 Newton. Okay, thank you.